Hello dear students, we are here with the class on Unit 3 of the subject Artificial Neural Network and Deep Learning. Unit 3 deals with two parts. The first part will give you an introduction to recurrent neural networks or RNN. The second part deals with overfitting and regularizations. So here I am today with the first part, that is RNN. So you can see the first part is RNN, and we begin with the need for RNN first. So why are we actually studying about recurrent neural network? So it's like whenever you want to deal with a data which has temporal dimension, then at that time you require recurrent neural network. Now if I talk about convolution neural network, which were used in visual type of input, or mostly they all deal with the images, okay, and this type of network, that is the CNN, it uses local correlation of the data and also weight sharing. So that has got to deal with lot of images or a visual data where you can have local correlation and the data which has got spatial dimension. Now if you are talking about a data like text, speech signals, or the data which can change with respect to time, which is sequential in nature, like stock market, okay, prediction of stock market, etc. So these are some data which are having spatial dimension as well as they are based on time, that is they have temporal dimension as well. Next. So such type of data which require a time dimension also as a variable, and such type of data also do not have a fixed length of data, okay, the length is dynamic in nature, okay. So such data will require a different form of neural network. CNN will not be useful for such kind of data. So that's the reason there was a need for another type of neural network which could handle such data like the text data, speech data, which have got temporal dimension as well. So there came the evolution of a new neural network called recurrent neural network. Next. So a recurrent neural network is a kind of artificial neural network which is mainly used in speech recognition and natural language processing. It is used in deep learning and in development of the models that imitate activity of neurons, like the human brain. So whenever we are working with such type of data where you are having sequences, okay, like text sequences, genomes, okay, where you want to predict the next spoken word, where you have got speech analysis, okay, and suppose you are working with the data which is being coming out of sensors which are based on time, then you have got stock market prediction which are again based on time, and also the data which are coming from some government agencies, etc. So such data which has got a temporal dimension, you would be using a recurrent neural network with it. Next. Now, when I talk about how does a recurrent network look like, the recurrent neural network looks similar to a traditional neural network, except that you have got a memory allocated to it. So, because as I told you, the data is sequential in nature which you are working. Now, sequential in the sense which should have certain amount of memory with it. So, whenever you are having a neural network with some added component of memory to it, we call it as a recurrent neural network. So, all you are going to do is to the computation of a neural network, you add a simple memory. Okay. So the recurrent neural network is a type of deep learning oriented algorithm which follows a sequential approach. Now we here believe that each input and output is dependent on all the other layers. Okay. So all the cells inside an RNN are dependent on each other. So because they perform sequentially the mathematical computation, they are called as recurrent neural network. So this was about introduction to neural network. Next. recurrent neural network. Now here you can look at this diagram. This is the pictorial representation of an RNN, where you could see that till now you have been using neural networks which were having input and then output coming out of it. But when I have got an RNN, you can see one of the part of the output, output is taken and fed back to the input, and this will be helpful to calculate the next output. That is, we tell that if at time step t I am taking an input xt and I am calculating the output yt out of it, then this yt will be taken ahead and will be given back to find out yt plus 1. Okay, so vice versa I can say that to calculate the current output yt, there have been the role of input xt and the previous output also, which I call as yt minus 1. So not, previously when we were working with other neural networks, you got x and y. I never used the terms xt and yt, but from now onwards I am working on some data which I am representing as x suffix t and y suffix t, because they are all dependent on time. Okay, so when I am having an input xt and an output yt, then I am not telling yt is obtained directly from xt or the current input. I am also telling that it is dependent on the previous output. So output is not only dependent on the current input but also the previous output. So suppose current output is yt, current input is xt, previous output is yt minus 1. Then the output yt is dependent on xt and yt minus 1. Alright, so I will be coming across this particular equation when I teach you mathematical model in certain time, but I hope this is understandable. So if I am talking about an output yt which is obtained by current input xt, it is also dependent on the previous output yt minus 1. So please make sure you remember this once we go to the mathematical model. Next. So I quickly introduce here with a simple example so that you understand an RNN better. So suppose I am giving you a scenario where you have got a chef who has got 3 dishes on his menu card: apple pie, burger and chicken, and you are supposed to predict what the chef is going to cook today. Next. So the cooking schedule is the weekly schedule, as you can see: Monday, Tuesday, Wednesday, Thursday, Friday and Saturday. Okay, so the sequencing is such that first the chef will cook an apple pie, then he will go for a burger the next day, then he will go for the chicken, again pie, burger, chicken. So from Monday to Saturday this schedule is fixed. Now if I ask you again the same question, what the chef is going to cook today, then you would ask me what the chef has cooked yesterday. If yesterday the chef has cooked a burger, then today he is going to cook a chicken. Are you clear? So that's how a previous output is helping you to find out the next output. I hope my example is clear here. So the same thing, if I want to predict what the chef is going to cook today and I give this to an RNN model, then what is going to happen? You will ask me what did the chef cook today? What did the chef cook today, so that you can find out what he cooks tomorrow. Now, so for an example, if I say that he cooked apple pie, then apple pie will be taken, the previous output apple pie is taken as an input. So now you can quickly predict what is the chef going to cook today. Yesterday if the chef has cooked apple pie, then today the chef is going to cook a burger. Next, if the chef has today cooked a burger, then the next day he is going to cook a chicken. So I hope that is clear to you how the present output is being served as an input and then you are predicting the next output. Okay, I hope this simple example makes you understand yt minus 1, xt and yt. Okay, next. So this is what you can say, that the overall model is working through a network of feedback, wherein the current output is fed back to the neural network in order to get the future outputs. So that's how an RNN also works. You require yt minus 1 also to get your yt. Okay, next. But how did I predict? How did I predict that what the chef is going to cook? So if I talk about the basic strategy over here, I have allocated every option which is available to me, every input with a vector value. As you can see, binary vectors I have allocated, and the type of encoding here used is one hot encoding. One hot encoding will give a priority to the value of one at a time, and it is not going to repeat. Like for an example, every significant place will have 1 at one time, and that represents one of the input. For example, here 100 is for apple pie, 010 is for burger, and 001 is 1. So in all these places, significant places of 1, the value of 1 has been changed to represent every input vector. And I club this together to form a simple RNN matrix. Now once I get that, next. What I am going to do, I have a simple RNN matrix, and then I have various options available, right? Next. So what I do is, now suppose the chef has cooked an apple pie first. No, just go back. Go back. Next. Yeah. Suppose the chef has cooked an apple pie first, and this is your RNN matrix. So apple pie matrix is 100. And this is RNN matrix, they both get multiplied, and then what you get here is C. When you multiply both of them, you get 010. 010 is an option for burger. Then burger gets multiplied with the RNN matrix, you get 001, which is an vector for chicken. Once chicken get multiplied, you get it as apple pie. So this is how sequencing of the input takes place with respect, in order to predict what is the next output. So the same strategy we are going to apply in RNN. Every word that comes across will be encoded into vectors, and then you are going to predict the next word out of it. I hope this simple example has made it clear how the input, how the past output and the input is going to give you a output. But let me make sure here I am not using any current value of input. Means I am just bothered here in this example where the previous output is predicting the next output. I actually did not give you what is the current dish or something like that, right? So there's only one situation or one condition where I explained you in this example where the previous output, how it can help you to predict the next output. Okay, next. So you can just see this is the simple vector calculation process which I just explained to you, and how it has been modeled into a neural network diagram. Next. So as I told you, if apple pie is there and you are giving it to a neural network, then it is going to produce a next vector which will be representing it for a burger. Alright. I hope it is understandable. So this is the internal model that is going to happen, which I told you long back, how feedback happens. That's the neural overview of how feedback is happening over here. Next. Now let's go for a complicated situation. Complicated situation in the sense, here as I told you in my previous example, I am just using the past output to predict the next output. Now I just want to make a situation a little bit complicated, wherein I am also using certain input values. So now I would say, instead of just the previous output deciding what could be the next output, how about I include current input also. So now the major part, like when I explained you about the block diagram of RNN, I told you current input and past output, both of them are going to decide the next output, right? So the same situation I am adding here to the example. So what I am telling here, instead of yt minus 1, yt minus 1 is the previous output. So previously cooked dish. So previously cooked dish is present, and current situation also I give you. Then you decide the output, okay? So I am telling that I now tell the chef that I now include weather also into this particular situation, wherein if the weather is sunny, the chef is going to cook the same dish as yesterday. Next. Whereas if the weather is rainy, the chef is going to cook next dish. Alright. So now what the chef is going to cook today. So based on today's weather as well as the yesterday. So you can see there's a little change that I did over there in the diagram. I've got two inputs here. So the previously cooked menu is apple pie and current input weather is rainy. So as I just discussed, there will be a change in the dish. The dish now will be the next dish, which is a burger. Okay, and then now the burger is your previous output, and then the current input is sunny. Then I'm going to cook the same dish. So what I get over here is a burger. Okay, I hope the situation is clear. Alright, so it's unlike before. What I am getting here is the present input, which is the weather, and the previous output, which was what was the dish that was cooked before. That is going to determine the output. Okay. So I hope that makes sense. This example makes sense how RNN is working. So now what I introduce here are two more conditions. So I have got two more vectors, 1 0 representing sunny, 0 1 representing cloudy weather. So apart from the previous vectors, now I have two more vectors to work with. Next. So I have now elaborated a bit more in terms of neural network. So the first one is the previous output, where it goes to this neural network where it represents food, and here it is weather. Both of them are combined together, given to a dense network, and then the next output is going to be predicted. So I hope you got the overview entirely of the RNN network, how things are going and getting predicted. Next. So I think it is very well understood in the diagram what all I have explained to you. Just have a look at the diagram, and as I already told you, there will be feedback of the output. Now mind it, the feedbacks of the output are going to only this part. So the upper part is dealing with the previous output, so the feedbacks are going to the upper part. Weather is the new input which is present, and as usual you have dense layer over here, and it gives you the prediction. Okay, so now this was the scenario of a normal functioning of an RNN. By the way, we have not moved much into detail of understanding mathematical models and all, but a practical simple example just to let you know how a feedback is working to determine a prediction of a sequential data. I hope it really works. In the next module, we are going to dive into some more other topics of RNN.